Hi there. So we're going to finish up video 13 of the College Math 2 final exam review, and we're still working on solving equations. And let me go back to our last location. We were solving quadratics, and we're going to do a mix of problems now. I have a few more problems to finish, and then for the rest of the problems that are on the after video 13, for the rest of the problems, I'm just going to give you the solutions and worked out solutions for them, even though you have the answers already. So right now I'm going to solve for x in problem number 33, and you want to square both sides and then check your answers. So with this, we're going to square the left and we're going to square the right, giving us x minus 1 is equal to 9, and then we're going to add 1 to both sides, giving us the answer x is equal to 10. Okay, and there it is. There you have it. There's our answer for the first problem. Okay. Then on the second one, we're going to factor x cubed plus 1,000. And if you recall, when we were talking about perfect cubes, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and then we'll skip up to 10 cubed is 1,000. Those are the most common cubes that I would say you have to know, but you can always check it with a calculator if you think it's a cubed, if you have an x cubed plus something. In this case, it's 1,000, so you probably know it's 10 cubed. So what you're going to do now is you're going to use to factor this, you're going to use a factoring formula. So if you recall a cubed plus b cubed, I use what was called the SOP method, same, opposite, plus, for the signs in this. And knowing that you have to get a cube, change over here. So a times a squared would of course give you the cubed, and then b times b squared would of course give you the b cubed, and then the middle term is just the opposite sign times both of the bases multiplied together. So the same sign for the first binomial, the opposite sign between the a squared and the ab, and then the plus sign for the last term plus b squared. Underneath of that, I've put the, it's going to erase some of that stuff. I've put the difference of two cubes. So we know this first one as the sum of two cubes. So if we want to make this expression a product, this is what we use. So instead of, I'm going to just take a step going from the first step to the second. I'm going to say, well, this is x cubed plus 10 cubed. So I'm going to say off to the side that a is equal to x, and then b is equal to 10, looking at the bases. So I would say that this is then equal to, go back to purple, the quantity x plus 10 times x squared, same, here's my same, opposite, minus, I'm going to multiply the bases together, a and b, so I get minus 10x, and then it's going to be plus 10 squared. And this is always plus. There's your SOP method. So then I get the quantity x, so I'm going to write this over here, x cubed plus 1,000 factors as x plus 10 times x squared minus 10x plus 100. There you have it. There you go. There it is. Okay. So that's problem 34. Okay. Problem 35 kind of relates to it because we're dealing with the same kind of problem. So problem 35, we've got y cubed minus 64. So my first step when I see a cube is I think, oh, is it the difference of two cubes here? So I'm going to rewrite it as y cubed minus, and 64 is one of those numbers that I had said before right here. So 64 is a perfect cube, so it's 4 cubed. Now you can always test a number. You can always put it in your calculator as, see what the cube root is of a number if you're not sure if it is a perfect cube. But 64 is one of those that I ask you to memorize. All right, so here we go. So we have the difference of two cubes. So I'm gonna just move things around a little bit here. So we have that first step, and I'll put that right here. And I'm gonna move this. This should not take too much space up. Maybe I'll move that down here. So I've got a cubed minus b cubed There's my form. So then all I need to do is plug in here. I have y cubed minus 4 cubed. So a in this case is y, and b is 4. So I get y minus 4. You know, sometimes the mistake is students will say y minus 64, but you've got to use the cube root of 64. So y minus 4 is equal to y squared, and then it's the opposite sign. Here's your SOP method. Here's the same, opposite, and this one's always plus. So plus 4 times y, and then you have plus 4 squared. We'll just write that as 16. And so here is your factored form. Kind of cool, right? So again, this will be a formula that you have on your formula sheet that I'll be sending to you. All right, so the difference of 2 cubes. Okay, and we have one more down here, 36. I'll do 36 and 37. It's a prime number, 37. So if you look at this, we're going to multiply and simplify, but I first want to see that the index is the same before I bring these two fractions together and using this rule. The nth root of a times the nth root of b can be brought together as the nth root of a times b. So that's what we're going to do here. We're going to say the cube root of 2 times 4, and then that's equal to the cube root of 8, and the cube root of 8 is equal to 2. Okay, and there you go. There you have it. There it is. Almost done. Coming around the bend. So on the last problem here, 37, I've got the quantity 5x minus 3 to the 2/3 power. And all we're asked to do is to use radical notation to write the expression. So here's the rule, where if you look at the index is m. So the index is the denominator of the rational expression. So when I look at this one, I say, oh, it's a cube root. So we end up with a cube root of the quantity 5x minus 3 squared. So we have it written in radical form now. And that's about all we need to do here. Okay. Maybe I want to look at the next page because there was one that I was thinking about doing and a little bit of time left on the video. So coming up to here, as a first step for number 38, I want to write this as a perfect cube. So you're going to use your rules in reverse. This would be 4x, the quantity cubed. Because remember when you have this, if you reverse this process, you would cube both of those factors to get 64x cubed. So we have the first term is going to be a perfect cubed, and then we have plus the second term is also a perfect cube because 27 is 3 cubed, and y cubed, we just write the y in there and then cube it. So what you would have, and I'll write this out pretty quickly, you have the binomial times the longer trinomial that you'll be writing out. So let me save a little bit of room here. So I've got 4x plus 3y times the quantity. Now 4x has to be squared, and then it's SOP method, opposite sign here, same, opposite, and then we multiply the two bases together. 4x times 3y, and then it would be plus 3y, the quantity squared. Simplifying that, then we end up with the quantity 4x plus 3y times the quantity 16x squared minus 12xy plus 9y squared. And there's your answer. Okay, for the next problem, if we solve this, we have it already in factored form, so it's like your a times b is equal to 0. So what you would say is that a is equal to 0, or you would say b is equal to 0 when you have a product equal to 0. So we're just going to take our factors, 2x equals 0, or 3x minus 4 is equal to 0. For the first one, we divide both sides by 2. We get x is equal to 0. That's one of our solutions. Or we have the second one, we're going to add 4 to both sides, and we get 3x is equal to 4, and then we're going to divide both sides by 3, and then we're going to get x is equal to 4/3. And there's our 2 solutions. Okay, so both of these would be solutions to the problem. And then where we have -8 to the 2/3 power, remember that this is the cube root of -8 squared. So it would be the cube root of 64. Okay, so that would be equal to, and we've already come across this one, the cube root of 64 is 4. Okay. Functional notation, let's go ahead and take one more and then I'll do the solutions and turn them in then. Okay, so we'll stop at 41. It's another prime number. So if we have the function f of x is equal to the cube root of 3x minus 40 here, we're going to let x equal to -8, and we're going to determine the value of f of -8. So remember that a function is just like a receptacle. We're changing our value of x, and wherever x is in the equation, then x is out and 8 replaces that. So we end up with the cube root of 3 times -8 minus 40, which is then equal to the cube root of -24 minus 40, which is equal to the cube root of -64. And remember, you can take the cube root of a number that's negative. You can't, if you take a cube root of a negative, if you take a square root of a negative number, you get an imaginary number. But in this case, we just get -4 for our answer. So f of -8 is equal to -4. Box that right up here. Okay. Okay, and the rest of the paper, what I'm going to do is I'm going to submit these as a completed form in your Schoology, but I'm just going to write out the answers for you. We're almost there, kids, so hang in there and make sure that you get your studying in before the final exam. Remember that you need a 73 or above to move on to college algebra. So you can do this, and if you are going to another school, I guarantee you I will write you a letter of recommendation to enter a college. I'm not sure if it'll be accepted, but more than likely it'll weigh heavily that you did go through this course and you should be a good fit for a college algebra class anywhere if you have passed this class and passed the final exam with a 73 or above. Go for it, kids. All right, you got a bright future. I'll be seeing you this week. Bye.